Page 20. This is a pretty wicked multiplication problem. So I'm going to need a lot of space on this page, I suspect. So 27,141 times 1,001. 1 times 1, 1 times 4, 1 times 1, 1 times 7, 1 times 2. I'm going to put in a placeholder for each of those zeros. Let me do it this way. Let's do that one right here. And then this one, right here. You can even put all of them in there if you need to see those. It all depends on your brain and how you can visualize in your head. I am not good at visualizing in my head, so for me that really works. And then we're ready to line up right under here with 1 times 1 is 1, 1 times 4, 1 times 1, 1 times 7, and 1 times 2. For me, this is incredibly difficult because I don't see things lined up well. So be careful. And I am definitely going to check this one because I know myself and I don't have any problems at all messing these up. I like D for this one, but let me just put this through my calculator to be sure I haven't done something wonky. When in doubt, check it out. And I know they want us to be able to do these without a calculator. That is correct. So I still just like to check myself. One side of a square room. I'm going to draw it if it's about a geometry problem. One side of a square room measures 15 feet in length. Because this is a square, that tells me that these sides are congruent, or they are all the same, exactly the same. Not similar, they're the same. If you needed cable to travel the length along all 4 walls, what minimum length would you need? Well, one wall is 15 feet. There are 4 of them, so I'm going to multiply to find this. I would need 60 feet minimum. That's with absolutely no waste. For me, I would probably need the 154. The minimum is 60. Okay. 11,287 times 1121. And I know already I'm going to need to move that over. All right. So I'm going to change colors. Maybe this would help you too. 1 times 7, 1 times 8, 1 times 2, 1 times 1, and 1 times 1. And then I will move over underneath that 2. Put the 0 in there if you need it. 2 times 7 is 14. Carry 1. 2 8s are 16, plus 1 is 17. 2 2s are 4, plus 1 is 5. 2 and 2. Let's pick up a different color. Line up under the next one. And I like to cross those off so I don't use them. 1 7, 1 8, 1 2, 1 1, 1 1. They don't make it easy, do they? And then line up under that thousands place. 1 times 7, 1 times 8, 1 times 2, 1 times 1, 1 times 1. And then we need to add this mess up. So we have 7, 12, 14, 15, 16, 17, 8, 10, 15, 7, 8, 10 plus 5. Let me check that again. There's 3, 4, 5, and 5. Okay. And then 2, 4, 6, 2, and 1. I will put my commas in here because I just can't read all that. And I'm going to assume that's right. 12,652,727. I'm going to check that just because I don't trust myself. If you and I were in a classroom together, you could tell me that it was correct. All right, number 31, we have to divide. So I have 634 divided by 2. The key to long division is keeping it lined up. 2 into 6 goes 3 times with none left over. Bring down the 3. 2 into 3 goes 1 time with 1 left over. Bring down the 4. 2 into 14 goes 7 times with none left over. So we say that this decimal terminates. And the answer is 317. 1,250 divided by 5. I know it's even because a number that ends in 0 is divisible by 5. 5 into 1 cannot go. But 5 into 12 goes twice. That would be 10. With 2 left, bring down the 5. 5 into 25 is 5 times with none left over. Don't stop. You have to bring down the 0. And 5 into 0 is 0. Still terminates, but don't lose that 0. It's a very common error. 851. This one looks like loads of fun. Divided by 23. 23 cannot go into 8, so we have to take it into 85. And if you don't need to do this, don't do it. I'm just doing it for those who may need to see this step. We know that 23 times 1 is 23. 23 times 2 is 46. 23 times 3 is 69. 23 times 4 is, 92? So I've gone over at that point. The answer I'm looking for is right in here. So we're going to say that it goes 3 times. And then I'll have to subtract here. 15 minus 9 is 6, and 7 minus 6 is 1. And then we bring this on down. And I'm going to have to keep going. 23 times 5. 23 times 6. Hopefully this is it. 23 times 7. Yes, that's it. And it terminates. I'm going to have to charge my pen for just a second. It's getting low. I need to charge it after this page for sure. Again, if you don't need to do all of that part of writing those out, that's fine. I just did that for the folks who may need to see that. All right. Then we have 851. That's what I just did. Sorry. 324 divided by 18. 18 cannot go into 3, and it goes into 32 one time. Bring down that 4, and we're looking for 18 into 144. I know that 20 would go into 144 about 7 times. So let's try that one. 18 times 7 is 7 and 5 is 126. Let's try 18 times 8. 8 eights are 64. 8, there it is. So it's 8 times, and it terminates. So I like 18 for that one. And I just didn't even mark this one, did I? 37 for number 33. 21,114 divided by 621. 621 cannot go into 2 or into 21 or into 211. So we're looking for 621 into 2,111. So just to get me close, I'm going to say 6 into 21 is about 3 times. So let's see what that gives us. And then let's try 4 times just to see if that's any better. And that is too much. So I'm going to go with the 3. 1863. And I can already tell you that 4 has to come down. So I have 11 minus 3 is 8. 10 minus 6 is 4. 10 minus 8 is 2. And look at that. I've already found it. It's 4 times 2,484, and there's no remainder. My pen would be dying on the long division page. While I charge it, let's take a look at this one. See if you can find the keyword. If it will take 21 cans of paint to complete 3 rooms of equal size, how many cans are needed for each room? Well, the keyword in the question is each. And to answer that, you would need to say 21 divided by 3 equal pieces. And that's going to be 7 times with no remainder. So you would need 7 cans per room. Luis is an iron worker. Luis's paycheck totals $2,480 after taxes. The paycheck was for 80 hours of work. After taxes, how many dollars did Luis make per hour? There's your division word. So 2,480 divided by 80. And I'm going to show you a shortcut on this one, and then I'll work it for you longhand. But this is worth knowing. You can cancel a set of zeros. You have to take an equal number top and bottom. 8 goes into 8 one time, and 8 goes into 24 3 times. So I am liking 31. But let's do it longhand and see if it still works. 2480 divided by 80. No luck there, no luck there. 8 into 24 is 3 times. 3 times 80 is 240. Bring down this 0. 80 into itself is 80 with none remaining. So either way you do it, you will get 31. I like canceling zeros, but you don't have to do that. If 4,380 concrete screws were used over 60 days of work, what is the average amount of screws used per day? Again, this is division. So you have 4,380 divided by 60. You can use the zero trick on this. I'll show you how. This is no luck, no luck. 6 into 43 goes 7 times for 420. Subtract 60 into 180 goes 3 times with nothing remaining. If you use the zero trick, you have 4,380 divided by 60, so we cancel the zeros. Now this one isn't quite as easy to do because it's not even division, but this would give you a smaller division problem if you wanted to do it this way. You would have 7. I'm not sure the zero trick helps much on this one, but you can surely use it. Either way, you get 73 concrete screws per day. Okay. 39. One electrical job requires 195 feet of wire, and a second job requires 225 feet. If the wire comes in 15-foot coils, how many coils will you need? So this is a multi-step problem. We're first going to have to figure out how much wire, how many feet of wire we need. One thing that you would always want to check here is that these are in the same units, and they are. We're dealing with feet. So first I'm going to say 195 plus 225. Let me do it vertically so we can add it together. That's 10, 12, and 4. So we need 420 feet of wire. 420 feet divided into those coils. No luck there, but 15 times 2 is 30. Go ahead and bring down that 0, and you have a 120 here. Now, if you know this, great. If you know it's 8, that's great. If you don't know, I would get close. I know that 15 times 6 is 90. 15 times 7 would be 90 plus 15, or 105. And 15 times 8 would be 105 plus 15, or 120. And that is the one that I need. So I like A. That's 28 coils of wire. Number 40. Gustavo has 930 plumbers and 31 projects starting at the same time. If he equally distributed all of the plumbers across all of the project sites, how many plumbers would be at each site? So this is definitely long division. The thing that gets divided up goes in the house. That's called the dividend. The divisor is the 31. Okay, 31 will not go into 9. And 31 into 93, I'm going to guess 3 times. And that's it. But be careful. You have not yet used that 0. 31 into nothing is nothing. And now everything has been used. So I like 30. And this is talking about plumbers. I'm going to charge my pen, and then we will tackle page 21.